The actual client is Victorian Government. They are delivering a number of level crossing projects in Melbourne under the level crossing removal program. It's the busiest rail corridor in Melbourne. They are a dangerous interface, but they're also creating a lot of congestion in the surrounding areas. So to take the trains away from the same level as the roads is the key purpose of the project. The project is to build elevated rail in 3 sections to remove level crossings. We are doing a 6-kilometre section, which is 3 kilometres either side of the rail line. So VSL was involved from the very start with the concept design. The idea was we need an overhead carrier system to transport and place the spans because any other method simply would not fit.
So it was important that we were able to design and construct a bit of machinery that was able to work and fit within the small spaces. The whole idea was to have a method where the trains kept running and we could still erect spans while the trains were running.
What we're doing is we're precasting the segments. The reason we're doing that is we just don't have enough room on site to cast a full span to set up a casting operation.
So the current number of segments for the entire job is 2,226. We produce 14 segments a day, 12 long line, 2 short line. We self-perform the reinforcement. We use a method of slice to prefabricate the outside dimensions of the segment shape. Pretty much no one believed at the start that this magnitude of production was achievable.
There's 2 parts to the span installation process. First is span assembly, which allows the segments to be unloaded and aligned next to each other. We then run strand and stress the span together to form a continuous span.
The advantage for the straddle is everything is above the bridge. It enables you to pre-assemble the spans in one location.
We then have the installation process, which is where we take the span, we put it on the deck of the existing viaduct.
So the basic gist of it is, so you have the straddle carrier, which is lifted up onto the deck with the gantry cranes. And then a span is lifted up to the deck, and then you have to lift the straddle carrier back over top of the span, and then the straddle carrier engages the span, lifts it up, and then it drives forward on an automatic driving system. So it's a magnetic driving system. It picks the straddle carrier up, and then it launches the straddle carrier up to its final position.
We have a very close operation with trains. So the key focus of the project is how do we manage that risk? How do we operate our equipment to avoid all that existing infrastructure? How do we maintain safety at all times? This project's certainly been a challenging job. We've been exposed to all the challenges that a main contractor has to deal with. It's really good to get a feeling when you're involved in some of the community engagement processes and people come up on the street and are genuinely excited. That's really nice to actually see that and to realise that we are doing something which isn't normal, isn't ordinary. It's quite unique and we're delivering it.